This first part, I'm going to introduce the concept of a coroutine, a little bit about how it works, and then we'll see a practical application in the next section. To start this section, one of the newer features of Python is this ability to define what's known as a coroutine function. It's going to look very odd, but I'm going to do a function where I say async def greeting name, and then I'll maybe return a result here, just saying hello plus name. This is a very unusual function. I mean, just the mere presence of that async keyword should give it away. But if you try to call this, like if I say G is equal to greeting Guido, you'll find that nothing happened. Well, at least nothing interesting happens. Like we don't get any output. And if you look at the result, what happens is you get this coroutine object greeting that gets returned. Essentially what a coroutine is it's a function that has to operate under the management of some other piece of code. It turns out that this function will not execute unless something else runs it. Now, one of the things that might run this code is a standard library in Python, such as the async.io library. We'll see more about what this is in the next part. What you do is you ask it for an event loop, and then there's a method on there where you can run something until it's complete. What's happening here is I've got this async function that I've defined. You call it, but some other piece of code has to run the function. Okay, it's a little bit odd. Think of it as a function that is running under management, though. Something is managing that code. Now, if you start writing programs with these async functions, they actually work like normal Python functions in that world. Like I could write another function like hello, for instance, where I have names is equal to Guido, Dave, Paula, or something. I can write loops where I start calling other async functions. Like I can say, print greeting name, for instance. This will work with the caveat that you have to use another piece of syntax to get it to run. There's an await statement that I'm going to use. So I'm going to write code that looks like this. So def hello, there's some names. Use the print statement. I'm going to use the await statement there. Turns out that this hello function is also one of these coroutine objects. Essentially, if you call it, doesn't really do anything, and it's not going to do anything until you feed it to some other code that can run it. So like run until complete H, then you'll see that code run. So this is a kind of an unusual feature of Python. You can write these async functions. They can call other async functions if you want. You could potentially even do things like recursion, for instance. I don't know why you would do this, but you could make like an asynchronous version of the Fibonacci numbers or something where you use the await statement. This would probably just really annoy people if you did this, but you can write a function like that. You can call it. You can say f is equal to fib of 10 or something. But again, something else has to run the code. If you run it, then it will kind of run the function for you. Having shown you this, you're going to wonder, like, why would I ever do this? Or like, what is actually going on here? And that's what we're going to talk about in the next part, about where this actually comes into place in practice.